So guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to look at exam style questions to do with finding the arc length in the sector area and as well dealing with compound shapes. But before we start, what I would like you to know is that you should be able to apply formulae of the Pythagoras theorem, the sine rule, cosine rule, the trig ratios, SOHCAHTOA, and as well you should be able to apply the area of a triangle rule, the one that says half AB sine C. Because with these exam style questions, what happens is that these formulae, they are all connected. So you should be able to know all of them and be able to apply them. So we're going to start off by looking at number one. With number one, we've got this, right? The sector ABC. And we are told that D is the midpoint of AC. So now, what does this mean? Right? If you're going to study these, we shall try and break them down step by step. So if D is the midpoint of AC, and we know that AC and AB are equal, it means that this is 4 centimeters, and as well as 4 centimeters, right? 4 centimeters, 4 centimeters. Now, first question says, find the length of the arc BC. So, number 1A, finding the length of the arc BC, we're simply saying S, or maybe let me write arc BC is equal to r theta, right? And r being 8 meters, so this is meters, not centimeters. So we're saying 8 meters multiplied by 0.65 radians, right? This shall give us the value of the arc BC, right? Which we are saying that 8 multiplied by 0.65 radians, we get 5.2. So 5.2 meters, 5.2 meters is the arc length BC, right? The second question says, find the area of the shaded region BCD. So we now want to find the area of this shaded region. But now, how can we do that, right? As we can see, we've got a sector ABC, and then we've got this triangle ABD, right? So what if we subtract the area of the triangle ABD from the area of the whole sector ABC, right? This means that we shall get the area of the shaded region. So now let's do that. This is now for part B. So we're saying the area of the shaded region is given by the area of the sector ABC minus the area of the triangle ABD, like this. And area of the triangle of the sector ABC is given by half r squared theta, then minus the area of this triangle, right? We're going to use the area of a triangle rule, which says half AB sine C. Why? Because we know these two sides and the included angle. So we shall say minus half AB sine C, such that now for the substitutions, our r is 8 meters. So 8 squared will be 64. Then multiply by theta, that's 0.65. Minus 1 over 2 AB. So our A is 8, then our B is 4. 8 times 4, we get a 32. Right? Sine of C, C being the included angle, 0.65 radians. Right? So now if you carry out the operation, we're saying that 32 multiplied by 0.65. So if you see 32 multiplied by 0.65, we get 20.8. Then minus 20 to 32, we get a 16. So we're saying 16 sine of 0.65. And then we get 11.1. So 11.1 shall be the area of the shaded region. Right? 11.1 square meters, like this. So this is how we do that. And then now for number 2, moving on to number 2. Number 2, we've got this shape and the triangle there. And then we know that this is a right angled triangle here. Right? Why? Because this tangent is touching the circle, right, at this point, right? whereby we've got the radius A, so we've got the right angle triangle, right? And we're also told that EC is equal to the square root of 65, so this distance, right, which is the hypotenuse of this triangle, is root of 65. So first part says find the size in radians of the angle DCE. So we want to find this angle. But what do we know? We know EC. So if we know EC and we let's say we draw the triangle, the right angle triangle by the side, means we've got this, right? So this is a 90 degree. This is the angle that we want. This is C, this is E, and this is D, right? So we're saying that this is 4 centimeters. EC, we are told that it's equal to the square root of 65 centimeters. So we know that if you've got this is the adjacent side. If you have to label the sides, adjacent side, hypotenuse side. So having the adjacent side and the hypotenuse side, we can use the cosine ratio to find this angle. Let's call this theta, right? Such that we're saying cos theta is equal to the adjacent side over the hypotenuse side, which is 4 over root of 65, and therefore theta would be arc cos, or the cos inverse of 4 over root of 65. Like this. This is how we are going to find our theta, and theta will be equal to so we're saying the cos inverse of 4 over root of 65, that will be equal to 1.05. So 1.05 radians, 1.05 radians, right? This is the size of the angle, of this angle. So here allow me to write this is 1.05 radians, like that. Right, this is the first part. And then second part says find the area of the shaded region, DEH. So DEH, we want to find the area of that. But what do we see? We see that if we calculate the area of this triangle, right, and then we calculate the area of this sector, right, CDH, if we subtract the area of the sector CDH from the area of the triangle CDE, we'll get the area of the shaded region. Is that right? Okay, so we are saying that area of the shaded region, so that will be area of the triangle CDE minus area of the sector CDH, right? So it's the area of this triangle, right? We can even use the area of a triangle rule, which says half AB sine C. Why? Because we know EC and we also know CD. So, and we now know the included angle. So we're saying half AB sine C minus area of the sector, radius given as 4, we're saying half r squared theta, right? So now making the substitutions, we're saying half A for the triangle, if we say A is EC, that will be root of 65, then B is 4, sine of 1.05 radians, minus 1 over 2 r squared. If r is 4 squared, that will give us a 16. Then times theta 1.05. Right. So now if you carry out this calculation, 2 into 4 we get a 2. So we're saying 2 root of 65, right, times sine of 1.05. Then you're subtracting that by, this is 8 times 1.05. 1.05. You get an answer of 5.59. So 5.59 will be the area of the shaded region. 5.59 square centimeters. Like this. This is how we calculate the area of the shaded region. Then now we shall move on to number 3, which is the last question. So allow me to erase this part. Okay, so now for number 3, we're told that we've got this. Now we're told that AD is an arc of a circle with center C1. So C01 here, then AD is the arc of the circle, right? So, and then radius is 6 centimeters. So I say we've got 6 centimeters here, right? C01A is 6 centimeters, and as well C01D is 6 centimeters, being the radius. Then AB is an arc of a circle with radius C2. So AB, okay, so now AB, there's now an arc, right? And then the center, right, of a circle with the center C2. So the center for this is D, right? And then now the size of the angle, this is all AC02D is 2/3 pi radians. We're asked to calculate the radius of the circle with center C2. So we need the radius, right, of this. In other words, we need to calculate AC02, right, or BC02, right? Either way, this is still the radius for that sector, right? So what do we see? We know that we can use this triangle. How can we use this triangle, right? We can use this triangle since we know that this, right, we can calculate this angle, right? So we can find this angle, and that angle, let's call it x. So angle x, right, angle x can be given by pi minus 2/3 pi, which is just 1/3 pi. Right. And then now if we know angle x and we need AC02, right, and this is a right angle triangle, and you know AC01, right? So leveling the sides of the triangle, this would be the opposite side, and we want the hypotenuse side, right? So opposite side, wanting the hypotenuse side, we can use the sine ratio. So we can say sine of x is equal to the opposite side, which is 6 centimeters, over the hypotenuse side, which we want, the radius, AC02, right? Such that AC02 would be 6 over sine of x being 1/3 pi, like this. So we can calculate that. So I'm saying 6 divided by sine of pi/3. We get an answer of 4√3, right? So 4√3 is the answer that we get. 4√3 is the radius, right? So 4√3 centimeters. This is the radius of the circle with center C02. In other words, this is AC02, which is also equal to BC02. Then the second part says calculate the area of the shaded region. So area of this shaded region, right? What we want to do is that if we calculate the area of the sector ABC02, right, and then we subtract it from the area of this region, right, this region, which is part of the sector. But now, how are we going to calculate the area of this region? Let's call this region Y, right? So that is region Y. So to calculate area of this region Y, we're going to say the area of the whole sector with the center of C01, right? Which is half R squared, R being 6, that's 36, R squared theta, and our theta being 90 degrees, which is pi/2, right? Then minus the area of this right angled triangle, right? So for the area of this right angled triangle, what can we use? We know AC02, right? And you know you can calculate this, right? this angle would be pi over 2 minus x. So we're saying pi over 2 minus pi over 3, and this gives us pi over 6. Right, so this angle is pi over 6. So we can use the area of a triangle rule, which says that half AB, so you know the side 6 centimeters, and the other side you calculated it as 4 root 3, right, times sine C, and the angle there being pi over 6, like this. So this will enable us to calculate the area of the region Y. So now we're saying this is 4, 9, so we're saying 9 pi, 9 pi minus, this is 3, so minus 3 root 3 sine of pi over 6, right, sine of pi over 6, right, that will give us sine Peri, okay, or let me rather write it as, yeah, that will give us 25.7, so 25.7, 25.7. This is the area of the region Y. So now we can calculate the area of the sector ABC not 2, then subtract with this. Right. So the area of the sector, AB C not 2 is half r squared. R squared, the radius, we calculated it as 4 root 3 squared, then times theta being 2 pi over 3. Alright, so this is what we have. So we're saying 4 root 3 squared, you get a 48, then times pi over 3, so times pi over 3, and we get 16 pi, right? So 16 pi is the area that we get here. Alright, and then in case here we didn't decide to round it off, it was going to be 9 pi minus, then we get a 3, here we get a 2, let's see, here we get a 3, and then that will be 12 root 3, so 12 root 3 sine of 30, that will be half, so that will be 6 root 3, right, in case we didn't decide to round it off, such that it will be now minus 9 pi plus 6 root 3, which will give us 7 pi plus 6 root 3 is the final answer, which you can just decide to simplify to be, so this, okay, this is the area of 16 pi. 16 pi is the area of the whole sector. The area of the shaded region is the one that is there. Right. So if we decided to simplify that, that would be 7 pi plus 6 root 3 to give us 32.4. So that would be 32.4. In other words, 16 pi minus 25.7. Yes. So this is what we get. Okay, so this was looking at how we would calculate, I would just apply the formulae of finding the arc length, the sector area to the exam type questions. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.